Hello everyone, my name is Victor Bryman. I welcome you all back to this channel. In today's class, we will be discussing solar panel parameters. So I have a small solar panel with me here. You can use this as a sample. So if you check the nameplate, you will see some parameters and values by the sides, so what we call the specifications. So I will be starting with the maximum power output. Solar panel parameters. 1. Maximum power, or what we call the Pmax. So the maximum power of this solar panel is 10 watt. This is a 10 watt panel. We have the output tolerance. We have 3. Current at Pmax. That is Imp. The current at Pmax here is 0.53 amps. The tolerance is plus or minus 5%. Then we have the 4th parameter to be the voltage at Pmax, what we call the Vmp. So the voltage at Pmax is 19.0 volts. Then we have the short circuit current. Short circuit current, ISC, which is 0.57 amps. The 6th one is the open circuit voltage. Which is VOC, and is 22.8 volts. So we have others we'll be discussing later. So let's finish with this first. So the first one, we have the maximum power. So on the panel, it is 10 watts. It's a very small panel. So what does it mean? This is the maximum power we can get out of this panel at standard test conditions. So what are these conditions? 1, the temperature should be 25 degrees Celsius. Then the second one is solar irradiance. Solar irradiance of 1000 watt per meter square. Then we have the third one, air mass ratio, that is AM, of 1.5. So these are the standard test conditions. So this is what solar manufacturers use all over the world. They use this to determine the output power, or the maximum output power of their solar panels. So that is that. Then we move to the second one, which is the output tolerance. There is always a tolerance limit. At times, you can get something little above 10 watts. And you can even get less than 10 watts. So this is the tolerance, plus or minus 5%. So if we apply 5% plus 5% to this, what we will getting is this. Is very simple. 5% of 10 watts. This is what? 0.5. Then multiply it by the 10 watt. This will give you 0.5 times 10. That is 1. That means you can actually get 11 watts out of this. And if we apply the negative output tolerance, that means we have to minus this away from this. That means we have what? 9 watts. The panel range of operation is between 9 watt to 11 watt. It means out of this panel, you can actually get, or between this and this, you can get 9, 9.1, 9.2, 9.3, 10 watts, 11.5, 11 watts. So that is the meaning of output tolerance. So how you can apply it. Just 5% times the maximum power. That is that. Then we move to the current at Pmax. Before then, your Pmax can be calculated. This is a formula for calculating your Pmax. It is I mass times Imp times Vmp. So this is the formula for calculating your maximum power. Now, what is Imp? That is the current at maximum power. The current at maximum power. So that is the actual current that flow from the solar panel under standard test conditions. That is what we call what? The Imp. So the value given here is 0.53 amps. The third parameter is, the fourth one is the voltage at Pmax. Voltage at Pmax, we have 90.00 volts. So the voltage at Pmax is the voltage that will be gotten at what? Maximum power. You know, we said the maximum power is 10 watts. So what is this voltage at this value is what we call the Vmp, the maximum power. It is the highest voltage that can be gotten out of this solar panel. Then we move to the fifth one, which is short circuit current. ISC. What is short circuit current? It is very simple. You know the meaning of, we all know the meaning of short circuit. If a positive and a negative cable bridge, that is what? That is short. And whenever short occurs, it means the resistance at that point is 0. So if the resistance is 0, the voltage will be what? Will be 0. So the current at that point will increase. So you see from this now, the short circuit current is actually higher than the current at maximum power. And if you are designing your system, you should pay attention to this short circuit current. The short circuit current should be used to determine your cable size, your breakers, the size of your breakers, your surge protective devices. It is very important because if a short occurs, your cable should be able to withstand the current that will flow. So do not use this to size your cable. This is the main parameter that should be used to size your cable and other devices, your circuit breakers and the protectives. That is just the meaning of short circuit current. Then we move to the fifth one, the sixth one, which is open circuit voltage, VOC. If you buy a solar panel and you measure the voltage, what you will be getting, that is before it is connected to your solar charge controller and linked to your battery. If you use your meter, your multimeter to test, what we'll be getting is what we call the open circuit voltage. It is the voltage on no load. Voltage on no load. The voltage you get out of the panel before it is connected to your load is what we call open circuit voltage. And the open circuit voltage is always higher than the voltage at maximum power. And this is very important if you are sizing your solar charge controller. You must ensure the maximum solar voltage is higher than the open circuit voltage, the net open circuit voltage of your solar sector. If, for instance, you are using a charge controller of maximum charge solar voltage of 195 volts, and your setup, you are getting an open circuit voltage of, let's say, 200 volts, and let the Vmp, the voltage at maximum power, let's say, is 190 volts. And you are thinking because this is lower than this, you are good to go. No, you must always ensure your maximum solar voltage is higher than the net open circuit voltage. Maximum solar voltage of your charge controller is higher than the net open circuit voltage. Because once your battery gets fully charged, the current becomes zero. And once the current becomes zero, I mean the current coming from the panel, because once battery is fully charged, current does not flow. So if you measure the voltage at the input terminal of your solar charge controller, at that moment, your battery is fully charged. What you'll be getting is your VOC. And if 200 volts is coming into a charge controller with maximum solar voltage of 195 volts, it will destroy it. So if you are designing your system, you have to pay attention to the open circuit voltage and the short circuit current. Very, very important. Other parameters we'll be discussing are the maximum system voltage and the maximum series fuse rating. Seven, we have the maximum system voltage, 1500 volts. Then 8, maximum series fuse rating is 10 amps. Now, what is the maximum system voltage? I know you'll be surprised that the value is this high. Yeah, it's telling you that this is the highest amount of voltage this solar panel can withstand. The circuit, the diodes and the junction box and the rest, the cables, the maximum voltage this solar panel can withstand is 1500 volts. It is not only just this solar panel, even the bigger one, it's just a standard. So if you are doing what is it called, any wireless, it is expected you don't go above this voltage, because any voltage that is higher than this, there's no solar panel that can withstand it. So that's just the simple meaning. But if you are doing an installation that the voltage has to be higher than this, let's say your net voltage has to be higher than that, means you have to bring in some equipment that will help to take care of the excess voltage. That's just the simple meaning of maximum system voltage. If you don't get it confused, it's telling you that this is what the circuit, the technology they use in this is also what they use in the bigger size of this. So what this one can withstand, what the whatever can withstand, is the same thing with the one that is bigger than this. Then we now talk of the maximum series fuse rating. What does this mean? It means this is the maximum current the circuit of your solar panel can take. This particular solar panel, the circuitry here cannot take more than 10 amps. If anything happens and more than 10 amps go into this, it can destroy the diode. It can even cause fire. So that is why if you are installing any system, you check for the maximum fuse rating of that panel. Each string, you must connect a fuse. And that fuse rating should be 10 amps, should be equal to or less than 10 amps. It shouldn't be more than 10 amps. Because if it is more than 10 amps, if maybe one of the string, let's say something happened, one of the panel short circuit. If you short circuit, you know the other panel will feed current into that particular panel. And if the current coming in, if there is no fuse, the current will come into the shorted panel. It will damage the diode or cause the panel to go up in flame. So it is very important. If you are installing your system in each of the string, try and install a fuse. Check for the maximum fuse rating of your panel. Then you install a fuse in each of the panel. You connect it to the positive cable of your solar panel. So that if anything happens in any of the string and the other panels have to backfeed, so this fuse will cut to protect the panel. So that is just the simple meaning of a maximum series fuse rating. It tells you that this panel cannot take more than 10 amps. So if you are installing it, you have to add a fuse, a 10 amp fuse, so that if anything happens and a current has to be backfed into the panel, the fuse can cut off to protect the panel. That is that. So with this, we bring today's class to an end. Please drop in the comment section what you feel about this class. Don't forget to like, share, and above all, subscribe. So whenever I drop the subsequent video, also hit the notification button so you'll be notified. Thank you. See you in the next class. Bye.